Hello, folks. Welcome back to TSQL for Beginners. I have updated the syllabus with the stuff we're going over today. So at our site here, litkind.github.io/tsqlbeginners, we have a new link here that says solution for the joins homework, and we are learning group by and case. So this links you to the files. I'll be going through the sample solution for joins. Let's go ahead and bump this up a little bit. That's file number 6. Then we'll be walking through just a little notebook that, like last week with the joins, it combines just images explaining group by and case. And then your homework for next week is up there too. So without any further ado, I've already got the files here. Let's start looking at those sample solutions for joins. So this is file number 5 _ joins _ homework. All right, so let me also go to the top of this file and bump up the font size a little bit there. And I need to connect to my SQL Server instance, charmingly. It's not really charming, named derp. Perhaps appropriately named derp would be a better way to say that. All right, so there was a bit of homework. The first thing we're going to do is use the master database, use the wide world importers database. It by default connected me to master because for my login, there's a default database associated with logins, and mine is set to master because on my test instance, other databases come and go, but master is always there. And that's generally what it defaults you to if you have sysadmin. In any case, there were instructions at the top of the homework that the questions in the homework, we're just using 2 tables. You can join more than 2 tables, but when learning just the ins and outs of the joins, I think it's easier to just work with 2 tables max, just in your very first thing. So we've got application.stateProvinces. That has, just looking at the columns in it, right? We've got an integer that is a surrogate identifier there. We've got a state province code. We've got a country ID. We've got a few columns there. And we can see the data types as well. And then a table named application.countries, which has, we aren't using too many columns from that in the questions. We're using a few of them. Latest recorded population, I think, shows up in the last question. So, and then we also, I mentioned that the join column between the 2 tables is the country ID. And if you need to work with tables and you don't already have a diagram of how the tables are laid out, one of the reasons why you might want a diagram is if I'm just working with these 2 tables, my first question is there a relationship between these 2 tables? In this case, they both have a join column named country ID. And I just hit a key there that made my windows go away. So let's go ahead and open that back up. We want join solutions. That's fun, Azure Data Studio. I hit and now we need to reconnect as well. Always fun to do it live. So we're also going to use we're back in Wide World Importer. So SP help. If you don't know, okay, do we have similar columns in these tables? We can see, here's country ID. It is an int. We can make sure that it's the same data type in both tables. Of course, we would also want to look at the tables and make sure that they don't just coincidentally have a column named country ID that isn't actually related to one another. Sometimes for a database, you'll get, an entity relationship diagram that describes the relationships between the tables. In this case, the identifier, I just did Control-R to bring that results pane back up. In this case, this column here on the countries table, if we look down at this, it is, there is a clustered primary key on this. This is the primary key of the table. In other words, it is a logical key. It uniquely identifies every row in the table. And due to a process of normalization, we aren't going to go through everything about database design and normalization. In fact, I don't know that I'm equipped to, but when we look at the application.state_provinces table, the reason that we've got country ID in there, if we look at the columns in there, like we could, for all of these states, we could show the country name in there. But the reason that this process of normalization has to do with, okay, if we give every country an identifier that's short, this surrogate key that's short, for this state provinces table, it takes up less space to refer to that country ID than it would be to the country name. And also it gives us the ability to join over to that other table in case we want things like the latest recorded population or other data about it. We wouldn't want to keep a column in this table for everything we want to know about every country, because we may have multiple state provinces in a single country. We want to keep duplicates of that, all of that information about the country. So this helps us keep country level information just once, and then that's the normalization bit. And then the fact that it's using an integer to record the country ID here, that's a surrogate key, and that's used for keeping the data sort of small and managing that relationship in the most efficient way possible. So whenever you're joining tables, the first step is just to figure out what is the relationship between these tables and what do I join on? And in this case, I've just, kind of given it to you there. All right, so on to the query writing. First challenge is to return two columns. We want to return state, province name, and country name. We want rows for all state provinces which have a related country ID. So we're going to join the state provinces table with the countries table, and we want only rows where there are matches in each side of this. When you want only matching rows, you want an inner join, which is just written as join sometimes. And that is here. If we look this out, this is one way to write this query. I've put application.state_provinces first. You don't have to. Like, I've written this two ways here. If you look at this the second way, I put, actually, no, sorry, they're in the same order there. In this second one, let's just go ahead and do that example of what I'm talking about where we switch the order. We could say, and I think I have it down there. We'll skip to that one. I was like, oh, we should show this. Then remembering that I already have it there. So first off, let's run this one and just show that this works. So running this, we want all state provinces that have a related country ID, and we aren't returning the country ID, we're returning the country name. We could also return the country ID if we're joining on it. We don't have to actually return the column that we're joining on. And what we see here is that the only rows in state provinces, all of these, they're all related to the United States. So we have many countries in the country table. The only country that has state provinces is the United States table. Now, this second query here, I wanted to skip over this. I'm so excited about the next bit. This next query here, this is the exact same as the first one. It just doesn't have the word inner. Inner, if you just say join, it will assume you mean an inner join. Inner is the default. Most people, I'm not saying it's a good thing to omit it. I would say that most of us are in the habit of just omitting it. So a lot of us, when we write T-SQL, we don't even think to stop and write the word inner. I would say just bonus points for you if you take the time to do it. But a lot of us just write the word join, which if it's not specified, it will do an inner join. If I run this query, it also returns 53 rows here at the bottom. So just zooming in there, we can see 53 rows. Now, what if we were to put this in a different order? This is what I was so excited about showing that I wanted to jump ahead. And I alluded to this last time. When we're writing T-SQL like this, what we're saying is we want to join these two tables together and get matching rows based on the rows where there's, a country ID in both sides. We are not telling the SQL server, just with this basic syntax, we aren't telling it, read from the countries table first and then read from the state provinces table in terms of how the query is executed behind the scenes. And we can see information about that. I'm going to highlight both of these queries and hit up the explain button. This is just showing the estimated execution plan. So it'll look at each query and it'll optimize. Hey, how do I think I want to run this behind the scenes? And the only thing to take away from this at this point, I mean, there's lots of interesting things you could look at in here, but the main point in this is we can see in the syntax here, yeah, it does have the different syntax. It's saying here, you can see my comments in there too, but notice that the pictures here are the same. Even though I listed the table in a different order, it can choose, SQL Server can choose to run this however it wants. And now I'm trying to do Control R and get rid of that query pane. And it's not wanting to do that. Let's go back to the results tab. There we go. If I go back to the results tab, then Control R behaves as I want. So this is actually good news for us. What we are worrying about when we write the T-SQL is what is the definition of the results we want back. We don't have to, if there's tricks we can get to later on about how to make it behave a certain way, but most of the time we don't. Most of the time it's really good at figuring that out itself. So with an inner join, right, this can be written in either order. It's identical. Question 2, we want to return 2 columns. And for this one, we want same 2 columns back. We want rows for all countries. And we only want the related state province name if it exists. You have a challenge to write 2 versions of the query, one with a left outer join and one with a right outer join. Left outer, when we use a left outer join, I'll go ahead and run this one. When we use a left outer join, what this is saying is that we want all of the rows in the left table. That is the table that we listed first. So it becomes left simply by being listed first. It is now on the left. So we want all of the rows in countries because we listed that one first. And then we only want rows from application.stateprovinces, which I've aliased as P. I aliased application.countries as C. I only want rows from this one if they matched, based on the country ID. So what we can see here is, all right, so our challenge, return rows for all country with a related state province name if it exists. Now, I did say return 2 columns. I didn't say you had to put them in a certain order. I have the country name on the right. So we should get 242 rows back. And I can see that down here, 242 rows. And if I scroll down through this, all of these don't have any state province names until we get to the United States. And we can see that for the United States, it's every row that it matches on that country ID, it will come back with a row for that. So we get more rows for the United States because it has, what was it? Was it 53 provinces listed for that? And then these, all have nulls next to them. So that's the left outer join. Right outer join, what we're saying is, okay, with the right outer join, let's go ahead and run this one. We want all rows from the right table. The right table is the table who's listed after the words right outer join. So if we say left, we mean the one that's before. And this makes more sense if we put it all on one line, right? Now, this is not the way we normally do syntax for this. But if I put this all on one line, then right actually does work, right? It doesn't mean below, it means to the right. So we want all of the rows, in this case, from application.countries, which is on the right, and only the rows from state provinces when they match. So this same trick works with left outer join. If you're ever getting confused and you can't remember, you can just put that on one line and that'll help you understand it. Most of the time, you will find that people do tend to do a syntax where they do put a return between these. So if you can get used to looking at it with thinking of right as just after and left as before, that'll help you with the way that people often just do their indentation in their syntax. But of course, you can have whatever syntax standards you like and that you want. That is all up to you. So all of the ones from countries, because it's on the right, only the stuff in state provinces as they match, we once again get 242 rows. I would worry more about learning left outer join, since that's what most folks use. In either case, you don't have to put the word outer in. See how this just says right join? You could say left join, you could say right join. It will just know when you say right join or left join that you mean an outer join. I would say this is also quite common for people to just say left join, right join. To do, inner join, we just write join, and we do left join, and then we do right join. Question 3, we only want one column name on question 3, and that is country name. This time we want rows for all country names which do not have a related row in state provinces. So all of the countries, now we already know from just the data that we've looked at so far that the only country that has state provinces listed is the United States. So if we want country names that do not have a state province, we basically want everything in the country table except for the United States. So this is a common pattern that you'll see, and you'll use this a lot in writing TSQL. I want everything in this that doesn't want a matching row in that. That pattern actually comes up quite a bit. And the most common way to write this, there's actually a couple different ways you could write this, but the most common way, and I think the most straightforward way, is the use of an outer join with a where clause filter added on. And when we look at how, we're going to look a little more later today, we're going to talk about group by at logical query processing order. In logical query processing order, this is just showing when the query is run behind the scenes, what order does it consider things in? And this actually can help you understand. You don't have to memorize this, but it can help you kind of understand how to write the TSQL. And this is documented. So Microsoft, you can see the page online where I pulled this from. It thinks about the from first. And then it'll look at all of your joins. And then after the joins, it'll do the where clause. So if I'm doing a combination of outer join and a where clause, it doesn't process those at the same time. It'll do the join first and then the where clause. And that's part of what makes this pattern work, as you'll see. Later on, it does group by and all of this stuff. It actually only does the select, farther down. And then at the very, very end, it does top. All right, so we'll be looking at group by and we'll be looking at having in the second part today. Let's look at this query. So we want all of the countries that don't have a state province ID. Let's just run this, take a look at this. We get 189 rows back there. And just to scroll down and see, we should not see United States in this list. Now, I don't have an order by in here, so order is not guaranteed, but it happens to basically be in alphabetical order. There is no United States in here. Right, and we would have 190 if we did. So here's how this works. And I think I'm only supposed to return one column, right? I got it wrong. Look at me adding in the country ID when it doesn't need to be there. So see, not even following the instructions myself. So we'll take country ID out of there. Look, it's fixed now. So we'll just pretend that never happened, right? There we go. So what I've done here is I've said, I went ahead and I find left join to be easier. So I always do left joins. I want all the rows in application.countries, which is, if I had that all on one line, it would be on the left. And I only want the rows in state provinces if they match. And then I say to accidental scroll. And then I say, since I only want the countries that do not have something in there, I'm saying with the left join, I want to see whether I have something there or not. Where country ID is null filters out all of the rows that would have matches, right? So if I run this without that where clause, I get 242 rows because what I've done here, the United States has all those different state province IDs matching up with it. But the United States is the only one. Notice that it's P dot, this scrolling is killing me. All right, we'll scroll very carefully. I don't know what I'm doing, but we'll just use the mouse. I'm having a day. P dot country ID is the state provinces table. It is aliased as P, right? So I'm filtering out everybody on this optional side of the join who has something there. If I was to make this C dot country ID, right? This would not give me the same result because I'm selecting from the countries table, but where country ID is null, that's not any rows, right? So I have to look at something on the right side of the join. I don't actually have to look at country ID. I could actually look at any other, you know, I think name is a column in it. I could look at any other, there we go. Let's just do state province name. So the state province table. So state province name is null, right? That will also give me 189 rows. There might be a performance benefit, but you know, you'll get the same results either way. So you can do p country ID is null. So there's a couple different ways you can write this, but that's essentially how it can work. You can write the same thing, of course, with a right outer join. And using the right outer join, you would just put the tables in a different order. Okay, so here is a little discussion. Hopefully, like this actually, I'm not sure if this discussion will help everyone. If you find it confusing, if you find this rewrite discussion confusing, just ignore it and look more at the pattern of outer join with a where clause. One question that I've gotten before when talking about this, that's why I bring it up, is sometimes this comes up as a question, is what if I was to do it like this? Instead of putting this and country ID is null, instead of putting that in the where clause, right? Up here, we have it in the where clause in both of these examples. What if we just put it in the join itself? Well, let's run this and let's see how many rows we get back. We get 190 rows back. We don't get 189 rows back. We get 190 rows back. And when we go down here and we look in the list, the 190, I mean, you know what the 190th row is, right? It's obvious. It's the United States. It didn't like reinvent itself as a different name. And the reason is that order of operations we talked about is really important. It looks at the joins and then it looks at the where clause. It's not able to, and in fact, we haven't given it away to. I haven't told it, do this bit first and then do this bit. It has to look at this all as one thing. And what I've actually told it here is, okay, I want it to match on the country ID and the country ID is null. This is effectively the same thing as writing this, where the country IDs are equal and the country IDs aren't equal. Like it essentially, if we look at what the query plan is for this, it actually only looks at the application.countries table. We have essentially kind of canceled out this join and it just writes it out of the entire query. So if we want to say, okay, I want you to look and see who has a match on the other table, that bit is done in the join. And then if we want to put a filter on that, that bit is done in the where clause. Now, there are other fancy ways you could rewrite this, but that's just the way it's done too, right? So trying to put just it all in the join clause won't actually get it done, because, and partly that's to do with the order of operations, but it's also because it doesn't, you know, we haven't kind of told it, yes, we want to do the match based on this column and then show that it actually doesn't have a match. You know, that's a two-step operation. All right. Question 4. We, again, want to return one column, which I've actually followed the instruction this time. And this time we're going to use the word distinct. We want to return a distinct list of countries which do have a row in state provinces. This should return one row. Because if we remember, if we don't use the word distinct here, if I comment out the word distinct, what we get is, if we're doing an inner join between countries and state provinces, the United States has 53 matching state provinces. So we get one row for every match, right? One row on the countries table matches 53 rows on the state provinces table. So we're going to get 53 rows back. And that, you know, if we were to add in the state province name, right, we would see why we get 53 rows. If we want to just know, okay, well, uniquify this. Just show me the distinct list. Get rid of any duplicates. That's what the distinct keyword does. So instead of 53 duplicate rows of United States, we just get one. if we happened to have two countries that had related rows in state provinces, right? If let's say we did have the provinces for Canada in that other table, then we would get, 2 rows back, right? So it just uniqueifies the list. Question number 5. For this one, we want rows for all country names and state provinces, even if the country does not have a related state province, or even if the state province does not have a related country. It is possible. Now, we know from sort of looking at this, actually, I don't know if we've checked. I don't know. We could actually have state provinces who don't have a matching country in the table. There are things called foreign keys that can enforce, you can only go in this table if you have a parent, but those foreign keys have to be set up in a certain way to ensure it. So, unless we've checked what's being enforced and if it is always, correct, we wouldn't necessarily know if we had state provinces who didn't have a country. A full outer join will say we want rows from both sides. If I go ahead and run this, we can see that, and I think how many rows do we get back for this one? I mean, it's 242 is what it is. It is the only table in here, and we don't actually have any orphans. It's just the United States who has rows in there, and we don't have any state provinces who don't have a country. That's a full outer join who will do that one for you. All right, question 6, and this is the next to last question. Question 6, we want every possible combination of country name with state province name and state province ID. And then we want to order the results in a given way. Now, in the question, it went ahead and said this is going to be a Cartesian product. So because application.countries has 190 rows, and we've got 53 in application.state provinces, we should get 10,070 rows back. This is what the cross join does. And notice that we don't have a join criterion. We are not doing cross join on country ID. We're just saying we want every combination of rows between these two tables. We want these 3 columns, and we want to order by these 3 columns. So let's go ahead and run this. And if the state provinces in the United States, if every country had those state provinces, this is what it would look like, right? So there might be, if we standardized the world based on these random, okay, they're probably not random, right? This is, if state provinces spread like fast food is what this shows. You would have them everywhere. And our final challenge from the homework is, this one I think is an interesting one. And this one is just, I didn't ever think about doing a self-join for a long time in TSQL. It doesn't come up a ton, but it can be really useful for certain things. So it's just kind of interesting. I think this kind of this kind of blew my mind when I first saw it. I was like, oh, of course you can do that. So the idea here is we want to select the country name for country ID equals 100. And then we want the latest recorded population for that country in column 2. And then in column 3 and in column 4, we want to figure out the country name that has the next largest latest recorded population. And then in the final column, we want to know its population. So essentially we want to know country ID, who's country ID 100 and what is its population in the first 2 columns. And then based on the ranking of all the populations, who has the next largest population and what is that country name and what is its population. So in this case, simple query to check your work. We're going to run that one first, right? So, and sometimes whenever I'm doing something kind of complicated in TSQL, I do actually often try to figure out, okay, how do I write the query? And then how do I write another query to verify my results? And the verification isn't always perfect. Sometimes I need to verify something a few different ways, but that always helps me out. In this case, just by browsing through these, we can see that country ID 100 is Indonesia. So these are going to be the first 2 columns, right? This data right here. And what we've done here, we've ordered by the population descending. So in this one, the next highest one, the next two columns we should see is Brazil in this population, right? So this is the answer that we expect to see if this query above here is correct. And I did give the hint of the way I was writing this is to use a self-join to get the result. You can join between a table and itself in TSQL, which is really cool. I mean, you could do this many times in the same query if you needed to. We have aliased this first one as C1 and the second one as C2. And SQL Server doesn't mind. It's like, oh, okay, this entity is a separate one than this one. And we can join, we don't have to join on an equals. You know, before we've been joining things where like, oh, you have the same country ID in both tables, so I'll find the equality. You can join on inequalities as well if you want to. You could join on a not equals. You can join on all sorts of things. But in this one, I can actually say, I want to join on the rows where the latest recorded population is less than the one in this table C1. So the table C1 is, we're finding just one row from that table. We're pulling back a row for country ID 100. And here we're saying, okay, we want to match with every row from the countries table, aliased as C2, but only every row that has a lower population. We are then ordering by that lower population descending. So they're all in that row and just taking the top one row. So this is, I mean, there's other ways you can write this too. This isn't not the only, I mean, this is going to be true for a lot of things. There are many different ways to write queries. There's usually more than one way to write a query, almost always. This, I think, is just a kind of cool one because it's a fairly simple way to do it. And if, let's see what we get here. Sure enough, checking our work, Indonesia here and Brazil here. And if we did, you know, top 2 or top 5, we would get multiple rows back, right? And it would be, okay, so here's the next highest one. Here's the one after that, the one after that, the one after that, the one after that. If you like queries like this, where it's kind of like, oh, I want to do ranking, things like that, we will be doing windowing functions and fun things later in the course. And there's lots of different ways you can do ranking and ordering and things like that. This is just one tiny little preview of ranking and stuff. All right, I'm going to close this file out. And actually, I'm going to go in here. This is just my little source control thing. And I think I'm going to go ahead and discard my changes in there. I know I fixed one thing that I'd made an error on, but I think I accidentally made other changes. So just so I don't save the accidental changes without thinking about it, I'll go back and fix that other thing later. All right, so for next week, we've got grouping and case diagrams. And I'm doing this in a notebook. Again, this week, this is just the discussion and demo. The homework is in a .SQL file, as always. So in my Azure Data Studio notebook, I'm going to connect to my instance. And the first thing we're going to do, just very similar to last week, we are creating, it's a different database. I think I named the database last week something different. The little database, it just has one table in it. We're back to one table for this week. At least for these demos, we're back to one table. We're getting a database named TSQL School. And today's demo is based on the Dog Rates Twitter and Instagram account. If you are not familiar with Dog Rates, and it does look like my query completed successfully, they rate dogs. And all dogs are rated out of 10, but they're all rated higher than a number out of 10. So you get a dog with 13 out of 10. It was just an excuse for me to use dog pictures and also to show that you can create tables with horrible names, right? Don't do this. Don't put an @ sign at the beginning of your tables. But we did in this case, which gives you good practice using annoying table names. This is just the demo. You don't have to do this in the homework. So I have inserted some rows into the table. And here is what we have doggos who have been rated. So Stormy is a corgi. He has 2 ratings. I rated him a 14. Kendar is my cave girl name. Fletcher is another dog. Fletcher only gave Stormy a 13. Fletcher, he's not that into Stormy. Fletcher, I gave a 14 out of 10. I thought he was really, really wonderful. And Mr. is another dog. Mr. rated himself. Mr. gave himself a 14, and I also gave Mr. a 14. So we're going to use this. Notice that we've got duplicates in this data, right? Stormy has multiple ratings. Mr. has multiple ratings, but not everybody has multiple. Fletcher only has one rating, and then some people have given multiple ratings too. So we have interesting things we can group as well as some numbers we can aggregate here. And these numbers are stored in an int column there. That's their rating out of 10. All right, so here's our logical processing order. We're first going to do group by, and then we'll be moving on and we will be doing halving. So here's a diagram explaining group by and count. Let's see if we can get our zoom to fit everything on the screen. That would be cool. This is the representation of the data in the dog rates table over here. And we've got the query in the middle. So we are selecting the doggo and then the count star. We are aliasing the count. This is a function, the count function. It's saying count all of the rows. We're aliasing that as tote. And then see over here the result sets on the right. We've got a column named doggo. We've got a column named tote. And we're pulling it from that dog rates. We are going to group by doggo. So what I'm saying in this query, we're going to first, looking at our logical processing order, from group by, notice that select comes after, right? So first we go to our from. Okay, we're pulling from the dog rates table. We're not doing any joins or anything like that. We want to group by the column doggo, right? So we start at the from, we go to the group by. We're grouping by doggo. This is Stormy. He has 2 rows. And we're just counting, right? We're counting all the rows. So Stormy gets a count of 2. He goes over here on the right. Next, we have Fletcher. Fletcher's here in the yellow. There's only one Fletcher. So we group Fletcher. He gets a 1. That's in the tote column over here on the right. We get to Mr. This is Mr., our little black dog. There's 2 Misters, so he gets a 2 over here on the right. Now you might wonder, why are they in this order? They're in this order just because this is just our query that we're running. If we expand it here, you can see the query. The query just happens to return it in that order. We don't have an order by here, so it can return it in every order it wants, and it happens to want to return Fletcher, Mr., and then Stormy with the same counts that we saw there. So that is group by with the count function. Similarly, we can use a max function. So we've got, that count counted. We did count star in that query. I just want to count the rows is what that asterisk means. And this one for the max, well, what do I want a max of? I want the maximum in this case of the rating out of 10. In the logical query processing order, we start at the from. Okay, we're working on this table. If we had any joins after that, they would then be calculated in. We are grouping by doggo. Once again, we're grouping by the dog name. That's what's in doggo. It's a varchar with their name in it. Although you could have an image column. It's not really the best practice to store images in your database, but you can. And then we're getting the max, and I specify a column name with the max rating there. So for Stormy, he happens to have 2 rows. Even if he had 50,000 rows, it would find what is the maximum value in the column we specified. His max is 14. Fletcher's max is 14. And Mr. has 2 rows. His max is also 14 there. So everyone's maximum score is 14. So if we run that there, sure enough, that is the result we see. Oh, just for fun, let's zoom. Zooming is fun. All right, minimum. Same thing, except it looks for the minimum. So it will group by, we're doing group by the doggo again. We're doing the minimum rating out of 10. Whether it has 1 row or whether it has a million rows, it will find the minimum value, right? Even if multiple rows have that minimum value, it will just say, oh, well, that's the minimum. I will return just that value. And so Fletcher's minimum is 14. He only has 1. Stormy got a 13. I mean, Fletcher, he gave Stormy that lower rating, and right, he's got the lowest rating here. Everybody else has 14, and we've got an example of that syntax there. So see, there's all sorts of, I think aggregation is one of the most common uses with group by. It's not the only use of group by. Sum, similarly, is another aggregation. In this case, we do the same grouping operation, and we just do the total of whatever column we've put in there. In this case, it is that rating out of 10. So we should see here 14, 28, and 27 respectively. Well, let's actually expand that so you can see that the query is the same. And sure enough, we do get those for sum. But what about average, right? You're like, this is so simple. Why are we going through every single one? Well, things can get a little strange with some functions. So with average, right? Like average is really straightforward. For Fletcher, has one score, his average is 14. Mr.'s average, right? 14. But wait, what about Stormy here? Because remember that column is an int. What is the average of 14 and 13 going to be like? I'm predicting it's going to be 13. Whenever you're dealing with average, you want to think about what data types you have and what data types you want to return. So this is just showing you that when we run the query with this data and this, we do get the average back of 13. So if you do want rounding in a different way, 13.5, we would assume that would round up. No, 13.5 didn't round up. If you do want more precision and you want to control how the rounding works with average, you're going to have to do a little more work. We can do a couple things here. One of the simple things we can do, and there's way more ways to handle this. This is just one of the simple things. I have actually now done a little math inside my average. So what I've done here, this is actually kind of a hacky solution. Not saying this is an elegant solution because it's not. I have said, I want to go ahead and turn this, and now I just crossed it out. I want to go ahead and turn this into a different data type. And the reason I didn't just say what data type it is SQL Server actually has multiple data types for decimals. It's got numeric, it's got float, right? So what data type is it turning into? Well, we actually haven't said. But if we look at the result here, we can now see that we get 13.5 back, which is correct. This will actually be returning, I didn't specify this here, this will return a numeric 38 length precision 6, right? So if you actually want specific precision or anything like that, you need to do some type conversion, and you will need to do it inside of the average, and it gets a little tricky. So just know average may not round like you think it will. So be a little careful look at your results, make sure it's what you want. All right. But max, min, and sum are all pretty straightforward. Next up, we're going to do a little bit of halving, and then we're going to go on to case. So with halving, this is back to our logical operations order, and let's zoom in a little bit, right? So it will do the grouping first, and then after it groups, it'll do the halving. This is useful because let's say we are doing something like a sum, and we want to say, we want everything, I want to group by the dog, but I only want everyone whose total ratings is more than X. We can do things like that. So here is group by and halving with minimum. Our query's gotten a little fancier here. So very similar. We're doing that min rating out of 10, just like we had before. So the top part of this query is before we have it's the min example from before, and we've just added on a halving here. So we want halving min rating out of 10 less than 14. So whose minimum rating is less than 14? There is only one dog that has a minimum rating that's less than 14, and that is Stormy. When we look at everyone else's minimum, and it will calculate what is their minimum row, and then compare it to, is it less than 14? So if we expand this out, run this query, this is Stormy, less than 14. What if I said less than 15? That should be everybody, right? Nobody has a 15. Everyone's minimum rating. In fact, everyone's maximum rating is lower than 15. So that brings back each of them with what their minimum rating is, right? But we were originally looking for this. We could, of course, also do an equals here. If we wanted minimum rating equals 13, we could do that as well, and that would be Stormy. If we did equals 14, it would be Fletcher and Mr. Right? So I think it's very, very cool that you can not only put these aggregations in your select clause, you can put them in the having clause. It will do the grouping first, and then it can apply your having. Now, can I do this? Can I say having tote equals 14? No. If I try to do this, invalid column name tote. Why is that? Okay, this is the select part. If we go back to our order of operations, select doesn't happen until after having. So we can use anything we alias in select. We can use it in the order by. This is why that order is important, right? So I can't use the alias there, but I can just copy the formula. It's extra typing. There is what that is. So let's reset this back to what was it, the original there. All right, so, and then if we run that actually does work if I haven't made it something invalid. Of course, we can also put a count in there. And this is, so now I'm saying I want all the rows for dogs who have more than one rating. I want to group by the dog, and then I'm just going to count the rows. Fletcher is the only dog who has one rating. So I should get back Stormy and Mr. there. Run the query. Sure enough, we only get Stormy and Mr. Our final adventure for today is case syntax. And case is really, really cool. And you don't have to use case with group by. We're covering these the same week, but it isn't that you can only use them together. They are very powerful when used together, and they are often used together, but you can absolutely use case without using a group by, right? So and we can even kind of look at that there too. And in fact, this query here is case without a group by. So this query is saying we want to select, from the dog rates column, and I do not have a group by here. We're just doing pure case. Essentially what we're doing is a conditional here. So first column, we just want the doggo. Really straightforward, right? So that one's clear. But then in the second column, we're going to say, okay, look at the rating out of 10. When it is 14, then I want you to return the character string boop. When it is 15, we don't have any of those, right? When it is 15, we're going to return blep. So there's no bleps in here because that one, it checks for it, but it doesn't find anything that matches. So we don't get that as a result. Else, otherwise return heck, right? So for the 14 ratings, we get boop. We have that one 13 rating that gets heck back. And we're aliasing the column corrected rating. Case lets you do all sorts of cool conditionals. And there are, there's a couple different ways of writing case. If there's a problem with case, it's just that it's a little confusing to learn because you can write it in a couple different ways. So this example is the case column name when syntax. So I have said case, look at this column. For everything following this, look at that one column, right? So when 14 just means when rating out of 10 is 14. When 15 means when rating out of 10 equals 15. So this is a nice compact syntax, but sometimes sometimes you want to do something that doesn't fit into this syntax. And there is another syntax that you can use with case. But first, let's actually run the query. Here's the actual written, same query we saw, but running against SQL Server. Sure enough, we only get one heck for that Stormy rating of 13, right? Because that just went into the else clause there. Okay, this is the second syntax of case, and it is case when condition. Last time, we had case immediately followed by the column name. This time, that column name isn't there. This time, it's case, and we go straight to when. And this lets you do things like when the rating is less than that, then heck, right? And you can make it far more complicated as well. But this one is just simply saying case when rating is less than 14, then do heck. And notice that I didn't put an else here. There's no else here at all. Else is optional. Else is often desirable, but else is optional. So what happens here, because we, when the rating is less than 14, we get a heck. So we have one row with a heck. Everything else gets a null because we haven't given it a case for anything else, right? These are all going to be nulls for the corrected rating. And if we run the query here, sure enough, we get those null characters back. Well, it just says null, but it's not the string null. It is a special thing called emptiness. It is the eternal abyss that comes back. Here it is getting fancier. So this is a compound condition with this syntax, right? So this time I'm saying, and I'm doing some concatenation here. I'm creating a sentence. So this time I want to concatenate the dog name. I did the plus here. And for creating strings and creating cases often used for this, case used for a lot of things. But I'm saying, okay, I want the dog name plus. If the dog name is the same as the rated by name, right? So if this dog rated themselves and the rating is greater than 10, right? So this syntax of case lets me I could say this and that and the other thing, or this. I can make it really complicated. Then is proud puppers. And then I put in this else blah. So we only have when doggo equals rated by. Well, there's only this one. Dog is not equal to rated by. Dog is not equal to rated by. Oh, Mr. rated himself. We have one row where the dog and the rated by are the same. Then it also has to check, is the rating greater than 10? Okay, all of this is true. So this one row is proud puppers. The rest all get explanation. The rest all fall into the else as the column labeled sentence. In TSQL, this looks like this, right? So this is how that runs there. One really important thing, whenever you are concatenating different columns, or whenever you're concatenating anything, whenever you're adding things together, one very important thing, what if I forgot the else here, right? What if this is commented out? What if we didn't have else there? We don't get like the dog name here, right? So what I was saying is combine the dog name with this other thing. One might think that without the else, I would get the dog name without the exclamation mark. Whenever you combine anything with a null, you get a null out of there. So anything, if you combine anything with the abyss, you get the abyss. So you have to, if you are combining strings or combining anything and there's nulls in there, be really, really careful how you handle that. It is this, since else is optional, it's easy to miss it. And you might get nulls where you thought you would get either an empty string or another string. So when you're using case, always think about your else's and think about whether it is okay to return nulls. All right, now we are going to get to combining group by and case. This can be really useful in aggregations. So this one, see, we're building up in complexity, and we're going to get having soon too. In fact, we're close to the bottom of the screen. We're close to the end. So this is an example where I can get complicated, and I can say, okay, I want the rows from dog rates, and I want to group by the dog. And what I want to do is look at when the dog is the same as the rated by, give me a 1, otherwise 0, and then end. So and then I'm summing that up for the dog. So essentially what I'm doing is for each dog, I'm counting the total number, that's the sum, the total number of times when they rated themselves. This is like creating a fake column on that row that I can then add up, is what to think of how this is doing this. That case statement is kind of creating, like it's looking at this and saying, I'm going to compare these two. Are these two the same? Okay, if so, picture a column here with a 1 in it. Otherwise, this one gets a 0. On this one, they're not the same. It gets a 0, right? So if Mr. had rated himself 3 times, there would be 3 rows that it would find, and he would get a 3 here. So you can do really, really interesting things with this pattern. I think this one's a really fun one to play around with for different things. And you can see here, this dog has 1 rating. There, the others have 0s. Another, there's a variety of fun things you can do with this in terms of, if you've got columns that have text in them, but you want to know how many times did this occur, then this is a pattern that can work well with that. Oh, and actually, we already did cover halving, didn't we? I was like, we're gonna cover halving. Well, let's double check. Let's make sure. Yes, there. We already did. We covered halving back there. This may be the 3rd time I've looked at this today. So I'm traveling backwards and forwards in time. So we have not 1,001 Dalmatians, but we do have quite a lot of dog examples there. So your homework, just a quick intro to your homework. You don't have a million questions. In the homework, there's only 6 questions. I didn't want the homework to be completely overwhelming this week. The homework here, there is some documentation if you want to take a look at, okay, what are the different ways we can do this? I linked to the Microsoft Docs there. Please do feel free to use the Slack channel for asking questions, for comments, or anything like that. And you're doing things like average quantity, aggregate the average of the quantity column for the entire table. Remember in the example how we were talking about decimal points? You can always go back to the example about that for more stuff. And then some more fun things here. So let me know if you get stuck and you need to get unstuck. But I hope that these query challenges are fun. I think they're really, really fun. And let's look ahead to just in our last minute here. So what we're doing this week in the homework is going back up to the top of the page there. So we're doing group by and case this time. Next week, we will introduce CTEs, subqueries, and derived tables. That I think is really, really cool. You can start making your queries more complex in interesting ways. And then we'll get into talking about some reusable code after that. So at this point, we'll talk about how to take patterns you've already learned and encapsulate them into functions of 2 different types and the pros and cons of functions. We'll get into more of those aggregations and things like ranking and running totals with windowing functions. And then we'll get to stored procedures too. So we've been kind of expanding things a lot. We'll continue to expand a bit, and then we'll start talking about, okay, well, how do I make these reusable and what are the different ways we can make code reusable? And I think that adds a different dimension to how you can use the TSQL patterns that you have learned so far. So thanks so much for joining me for TSQL for Beginners again this week. I will see you again next week. Have a good one, y'all.